So this is a great little z-score problem. So 3-month-old Benjamin Chance weighed 13.9 pounds at 3 months old. Is 3 months old. The national average for a weight of a 3-month-old baby is 12.5 pounds with a standard deviation of 1.5. So we have an N 12.5, 1.5 model. So I'm just going to start out, since I know I'm going to need this eventually here, I'm going to make myself a little diagram. And I'm going to put right in the middle here, this is X bar, my mean, which is also 0 standard deviations from the mean, because 0 standard deviations from itself. And I'm going to go 1, 2, 3, -1, -2, -3, and I number them up here, 1, 2, 3, -1, -2, -3. Those are how many standard deviations I am away from the mean. And I'll put my numbers in. So I know that the mean is 12.5. So that means the first standard deviation would be 14. And then I'd have 15.5, and I'd have 17. And then going the other way, this is going to be hard for me in my head. I'm going to have 11, and then take away 1.5. I'll have, take away 9.5, and take away 1.5. I'll have 8. So these are the numbers that represent the values for each of the standard deviations away from the mean. So Benjamin at 3 months weighed 13.9. So let's just kind of mark him in there. So 13.8 is not quite right there at 14. So I'm just going to make a line right here on this side of 14. And he's at 13.9. So I need to find his z-score. So here is the formula you really need to remember. Z equals X, which is our data point, minus X bar, which is the mean, divided by S, which is the standard deviation. In other words, I'm taking the difference between the mean and the standard deviation and actual data point, and I'm dividing it by how many units the standard deviation is. I'm getting how many standard deviations. So in this case, I have 13.9 minus 12.5 divided by 1.5. So I'll do that on the calculator. 13.9 minus 12.5. And I divide that by my standard deviation, which is 1.5. And I get a z-score. So z equals 0.933. And that sounds pretty reasonable to me because I see that 13.9 is between 0 standard deviations and 1 standard deviation. So 0.933 makes a lot of sense to me. So that's pretty good. That's the answer to the first part. Now for the second part, I'm dealing with a 6-month-old. So I got to remember for the first part, the z-score was 0.933 with a repeating 3. Okay, so for a 6-month-old, we know that the national average, we have an N 17.25, 2.0 model. So obviously heavier weight and a little bit more variability. Makes sense. So 0, 1, 2, 3, 1, 2, 3. So -3, -2, -1. This is 0 and is also my mean. And here's 1, 2, and 3. And I know my mean is 17.25. And my standard deviation is 2. So that would make this 19.25, 21.25, 23.25, and going the other way, I have 15.25, 13.25, and 11.25. Okay. So what would Benjamin's weight have been at the age of 6 months in order for him to have the same z-score at 6 months that he had at 3 months? Well, we know his z-score at 3 months was 0.933, and that was kind of like right in here, you know, close to 1, but not quite at 1. So I'm going to go z equals 0.933. And what I'd like to find then is the actual weight that he would have to weigh at 6 months to have that same z-score. Well, I'm going to go back to my formula. Z equals x minus x bar over s. Well, what do I know in this formula? I know z is 0.933. I don't know this because that's what I'm trying to find out. What weight would he have to be? So I have x minus x bar. I know that. That's 17.25. And I know s is 2. So now I just have an algebra problem. It's going to be 2 times 0.933 is equal to x minus 17.25. So let's take my 933 up here and multiply by 2. And I get 1.866. So this is like 1.866. And that equals x minus 17.25. Well, I'm solving for x here. So I think what I'll do is I'll add 17.25 to both sides. So let's add 17.25. And I find out that if he weighs 19.0, let's call it 0.07 pounds, so x equals 19.07. And that looks like a reasonable answer to me, not only because I did the math correctly, but because if I was all the way at 1 standard deviation, he would weigh 19.25. But I'm a little bit less than 1 standard deviation, so 19.07 makes a lot of sense.